And hello everyone and welcome back to another video. It's your boy Abhi here. And today I came across this weird looking integral which is 0 to 1 tan inverse of x to the power cube plus x squared times trilogarithm of minus x cube. Well, this may look like a little complex, but it's actually easier than it looks. So what we need to do is first, let's take this part as I1 and this part as I2. So let's solve the I2 part first because it's easier than the I1 part. So when taking that I2, which is equals to 0 to 1 x square trilogarithm of minus x cube dx. Doing a little substitution, let's take uh, x cube equals to t and we'll have 3x square dx equals to dt. And the boundaries will become the same as before, so we don't have to worry about that. So what we'll have here is 0 to 1 uh, 1 over 3 dial trilogarithm of minus t dt, and we know that 0 to 1 trilogarithm of 3 is actually sigma, and from 1 to infinite minus t to the power n over n cube dt. Well, this is actually, we can get the sigma outside the integral and we'll have n from 1 to infinite minus 1 over n cube 0 to 1 t to the power n dt. And okay, cool. So we'll have 1 over 3 sigma and from 1 to infinite minus 1 to the power n over n cube. Well, when integrating this part, we'll have t to the power n plus 1 over n plus 1 from the boundaries 0 to 1. And by some simplifications, we'll have finally that 1 over 3 sigma n from 1 to infinite minus 1 to the power n over n cube time n plus 1. And okay, so when doing some partial fractions here, we'll get 1 over 3, let's parenthesis, sigma n from 1 to infinite, the partial fractions will become 1 over n minus 1 over n squared plus 1 over n cube minus 1 over n plus 1 times minus 1 to the power n parenthesis. Okay, cool. So let that 1 over 3 outside the parenthesis, and by giving the sigmas to each and every one, we'll get n from 1 to infinite minus 1 to the power n minus sigma n from 1 to infinite minus 1 to the power n n squared plus, and it goes on. And parenthesis. Okay, well, we know that for this part we can use the natural logarithm of 2, and for this one we'll have pi square over 12, and this one is actually minus 3 over 4 zeta of 3, and for this one we'll have minus natural logarithm of 2 minus 1. Okay, cool. Let's move on to page number 2, and the answer we'll have for the I1 is now actually will become I1 is equals to 1 over 3, we'll have parenthesis pi square over 12, and we have 2 times ln 2 minus 3 over 4 zeta of 3 and plus 1. Okay, cool. Let's multiply that 1 over 3 inside and we'll finally left with pi square over 36 minus 2 over 3 ln 2 minus 1 over 4 zeta of 3 plus 1 over 3. That's the answer for the I1 part. Okay, now let's move on to the I2 part. I'm terribly sorry about that. This is actually I2 and now we are going to solve for I1. So the answer we have here for I2 is actually pi square over 36 minus 2 over 3 ln 2 and minus 1 over 4 zeta of 3 plus 1 over 3. And what we have for I1 is actually 0 to 1 tan inverse of x to the power cube dx. Well, for to trying to solve this one, first we need to do is partial integration. Well, we can take the x tan inverse of x to the power cube. Now what do we have here? It's actually 0 to 1 3 tan inverse of x to the power square times x over x square plus 1 and dx. Well, for plugging in these values for this one, we'll finally left with pi cube over 64 minus 3 times doing some partial integrations for this part, and we'll have half. Let's take the 3 outside so we don't have to worry about 3 anymore. We'll have half ln x square plus 1 times tan inverse of x to the power square 0 to 1 minus we'll have half 0 to 1 2 tan inverse of x to the power 1 and ln x square plus 1 dx. That's it. Okay, cool. So when plugging in these values, we'll finally left with pi cube over 64 minus 3 by 2 ln 2 and pi square over 16 actually, and plus 3 by 2, and these two will actually cancel each other out, so let me write that 2 0 to 1 tan inverse of x ln x square plus 1 dx. Okay, cool. And I forgot to differentiate the tan inverse of x, so we'll get x square plus 1 here as well. So what we'll have here is x square plus 1 dx. Okay, so what we'll have here is finally for I1 pi cube over 64 minus 3 pi square ln 2 over 32 plus 3 times 0 to 1 tan inverse of x ln x square plus 1 over x square plus 1 dx. Okay, so let's take this part as I3 and let's solve the I3 part. Well, now I3 is actually 0 to 1 tan inverse of x times ln x square plus 1 over x square plus 1 dx. Let's do some substitution here. Let's take x equals to tan theta. So differentiating both sides with respect to x, we'll get dx equals to secant square theta d theta. And the boundaries will become when x approaches 0 and theta will approaches to 0 too, and when x approaches 1, that theta approaches pi by 4. And let's move on to page number 3. So now I3 will become 0 to pi by 4. Let's, for tan inverse of x, we can write theta, and for ln 1 plus tan square x, tan square theta, and we'll have over 1 plus tan square theta as well. And for dx, we'll have secant square theta d theta. We know that secant square theta is equals to 1 plus tan square theta. So we can cancel these two again. So what we'll have here now? We'll have 2 times 0 to pi by 4 theta ln secant theta d theta. We know that secant theta is actually 1 over cosine of theta, so we'll have minus 2 0 to pi by 4 theta dot ln cosine theta d theta. And here we go. And we know that cosine theta is equals to e to the I theta plus e to the negative I theta over 2. So let's substitute this part. So we'll get minus 2 0 to pi by 4 theta dot ln e to the I theta plus e to the negative I theta over 2 and d theta. Okay. So by the properties of logarithm, we'll have 0 to pi by 4 theta ln 2. I forgot the 2 actually. Okay. Minus 2 times 0 to pi by 4 theta dot ln e to the I theta plus e to the negative I theta d theta. Well, when solving here, we'll have ln 2 theta square over 2 0 to pi by 4 minus, and we'll do some trick here, which is e to the I theta. We can write this one as 1 over e to the I theta d theta. So for this part actually we'll get this 2 will cancel each other out, so we are finally left with pi square over 16 ln 2 minus, and here we have 2 parentheses 0 to pi by 4 theta ln e to the 2I theta, wait, e to the 2I theta plus 1 d theta minus 0 to pi by 4 theta times ln e to the I theta d theta. Okay, cool. So now we have two integral here, which is pi square over 16 ln 2 minus 2 times 0 to pi by 4 theta ln 1 plus e to the 2I theta d theta plus 2I theta. I'm terribly sorry about that. We'll have plus 2I 0 to pi by 4 theta square and d theta. Okay, well, now let's solving this part. We get pi square over 16 ln 2 and plus 2I times theta cube over 3 from 0 to 1, and this integral will be here, which is 0 to pi by 4 theta dot 1 plus e to the 2I theta d theta. Okay, when plugging this value, we'll have pi square over 16 ln 2 plus I times, terribly sorry about that, I times pi cube over 68 minus this integral portion, which is 0 to pi by 2 theta times ln 1 plus e to the 2I theta d theta. Well, now let's name this as I4. So we'll get I4 is equals to negative 2 0 to pi by 4 theta times ln 1 plus e to 2I theta d theta. Well, when doing some integration by parts, we'll get dilogarithm of minus e to 2I theta over I times theta, which is from 0 to pi by 4, and we'll have minus I times 0 to pi by 4 dilogarithm of minus e to 2I theta d theta. Well, let's plug these values and we'll get pi over 4I dilogarithm of minus I minus, we'll get here I times 1 over 2I trilogarithm of e to the 2I theta from 0 to pi by 4. And okay, so what we'll have here is pi over 4I. We know that dilogarithm of minus I is pi square over 48 minus I times g, where g is the Catalan constant. Well, in here, this side will cancel each other out, so finally left with half trilogarithm of minus I and minus trilogarithm of minus 1. Well, now it's easier for us to solve this. It'll become minus pi cube and minus into minus plus. So pi cube over 4 times 48 times, we'll never forget that I. And now here we'll get pi over 4 times g and minus half. We know that trilogarithm of minus I is actually minus 3 over 32 zeta of 3 minus I pi cube over 32. And this part with the minus will get 3 over 4 zeta of 3. And here we go. Let's take the real part outside, so we'll get minus pi over 4 times g, and when adding these two guys we'll get plus 21 over 64 zeta of 3. Now let's take the imaginary part outside, so we'll get pi cube over 4 times 48 and plus pi cube over 32, and yeah, that's it. That's only the case here. So let's just keep those things there. And okay, so this is the answer for I4. So let's sum it up. We get I3 equals to, let's rewind it. This is the I3 part, so we get pi square over 16 times log 2 plus I times pi cube over 68, and we have this part where I4 is equals to minus pi over 4 times Catalan constant plus 21 over 64 zeta of 3 and the imaginary part of it, which is I times pi cube over 4 times 48 and plus pi cube over 32. And okay, well, we don't need these imaginary parts outside, we only need the real part of the answer. So we'll get, so the real part of I3 will become pi square over 16 ln 2 and minus pi by 4 and the Catalan constant plus 21 over 64 zeta of 3. Well, we got the answers for I3, and now we need to look up the question. Well, here we go. So I1 is actually, here we have this part. So let's go. So our target integral will become I1 is actually pi cube over 64 minus 3 over 32 ln 2 pi square and 3 times the real part of I3, which is pi square over 16 ln 2 minus pi over 4 times g plus 21 over 64 zeta of 3. Well, let's do some simplifications here. So we'll get pi cube over 64 stays as it is, plus it'll become 3 pi square log 2 over 32 minus 3 pi by 4 times g plus, and what we'll have here? We'll have 63 over 64 zeta of 3. Well, this is for the I1. Here, our required integral is I equals to I1 plus I2. We already found the I2 and I1. Now it's time for us to add these two guys and see what the real answer is. So we have pi cube over 64 and plus 3 pi square over 32 natural logarithm of 2 minus 3 pi by 4 of Catalan constant plus 63 over 64 zeta of 3 plus, remember the answer we got for I2 earlier? It's always in the upside. Here we'll have pi square over 36, and we have a lot of things, 4 parts there. So now it's time for us to add those guys. So it will become pi square over 36 and minus 1 over 4 zeta of 3 and plus 1 over 3 and minus 2 over 3 natural logarithm of 2. And let's add these guys, and we'll have pi cube over 64 plus pi square over 36. So these guys will cancel, and plus 3 pi square of 32 ln 2 and minus 3 pi by 4 Catalan constant and plus 47 over 64 zeta of 3 plus 1 over 3 and minus 2 over 3 natural log of 2, which is the long looking gorgeous answer we have here. This will become the final answer of us, and that's it. It took pretty long than I expected, but we finally found the answer. And that's it for tonight, guys. We'll find another integral in this coming Saturday. Until then, bye bye from Abhi, and don't forget to subscribe my channel. That's it. Bye everyone. Bye.